Hi everyone. Today we're going to be learning a little bit about the history of Earth. Let's just jump right in because this is really going to be a lot to squeeze into one video. All right, so over time, I think at some level, all of you understand that Earth has changed immensely. Whether it's just that you know that dinosaurs existed a very long time ago, or it could be that you think about mammals during the Ice Age, like woolly mammoths or saber-toothed cats. But the thing that I need you to keep in mind is that Earth is, well, it's changed a lot and it's a lot older than we sometimes imagine it to be. So, how do we know? I mean, how do we know that the age of the Earth and how do we know that Earth is very old and how do we know dinosaurs existed? Well, quite frankly, the way that we know about Earth, particularly Earth's history and its past, is that we study the rocks that are part of Earth and we also study fossils that are preserved in them. And by studying these two things, the rocks and the fossils, scientists over the last couple of hundred years have really been able to piece together a pretty good picture of what it was like on Earth in the past. So let's start out by sort of getting to the bottom of how old is the Earth. Well, the Earth is over 4 billion years old. I think the current value for the age of the Earth is actually 4,543,000,000 years old. So now that seems very specific, and some of you may be wondering, how do scientists know that? How is it that we can know that Earth is 4 billion years old? There was no one around to see that. Well, so scientists are able to, when we study rocks, we're able to actually, by taking the rock and looking at radioactive elements inside of it and analyzing those radioactive elements, we're able to determine the exact age of a rock. We know when a rock formed. So when we say the age of the Earth is 4 billion years old, that's because we found rocks and minerals that are about that old. And so, being able to date rocks has been immensely helpful to geologists and to scientists who are studying the Earth. And so, this is something called radiometric dating. You can learn more about it very easily, but it is a very reliable method for getting the date for a rock. So, we know how old the rocks on Earth are. So, if the rocks, which make up the geosphere, are most of Earth, then we know how old Earth is. Now, so we know the age of the rocks. So if we know the age of the rocks, fossils are those traces of ancient life. We've been able to also put together the history of life on Earth. So let's suppose that we find a fossil of a woolly mammoth inside of this layer of rock up here. Uh, so if we date the age of the rock and we find that that rock is 25 million years old, well, that fossil had to have been buried in sediment and then turned into rock with the fossil already in there. So we know that that fossil is going to be about 25 million years old. So we also know some things like the deeper down we go, the further down we go, the older the rocks generally become. This is something called superposition. So we can date the rocks and then we can also get an idea of which types of animals or which type of life came first here on Earth. And so we've been able to put together a really accurate timeline that helps us understand what types of life appeared here on Earth first. So I want to dig a little bit into sort of this history of life on Earth and how Earth has changed. And I want to just sort of start out and have you think about the fact that Earth formed, well, when the solar system formed. Our solar system formed out of what's called a nebula, which is a giant cloud of gas and dust. The center of that nebula began to condense. It began to sort of be squeezed together. And that's where our star formed. Well, when our star formed, uh, the planets are also what formed out around this star. This is something called the solar nebula theory. And so our solar system formed about 4.6 billion years ago. How do we know how long ago the solar system formed? Mostly we test the rocks that that we're able to get from space. We test things like meteorites and bits and pieces of asteroids. These are some of the oldest rocks that we have in our solar system. So by testing them, we've been able to date the age of our solar system. So when we look at Earth's history, we have to talk about something called eons. And eons are really just a very long period of time and often millions of years. So what scientists have done is they have broken Earth's history, this over 4 billion years, into four separate eons. And so the first eon is called the Haitian eon. Then we have the Archean eon. Then we have the Proterozoic, and then the Phanerozoic eon. And so please, we have the dates for these out next to them, and this gives us some basic times for each one of these different eons in millions of years. So as we look sort of at how Earth may have changed, I kind of want you to get an idea that at one time here, Earth was really just a ball of molten rock, and it was being bombarded from space. And then Earth cooled down, but we still didn't have any water. Eventually, we did have a shallow ocean that covered the entire planet, and just a few bits of land early land that had formed. At one point in Earth's history, we had what was called snowball Earth, where it was most of the Earth was completely frozen over. And of course, this would give us an idea. This is a image of the Earth as we see it today. So over these eons, Earth has changed a significant amount. Earth has been through many, many, many changes in both its geosphere, in its atmosphere, in its hydrosphere, and quite frankly, for most of Earth's history, there hasn't really been much of a biosphere. There hasn't been much life. So let's take a little bit closer look at the Haitian eon. So Haitian is actually a word taken from Hades, which was sort of that was the Roman underworld, which was, hell. So Earth, this is a period that Earth formed in. During this point, it had no surface, it had no oceans, no life. There was no solid crust. Most of the surface of the planet was not cooled. It was like this huge lava ocean. And during this period, it was continually and heavily bombarded by asteroids and other bits of space rock. There was some bit of atmosphere that was surrounding Earth, but it would have been poisonous to life, and it was completely unbreathable. And so, as we look over here, we have some of those important dates for the Haitian eon, but this is a pretty good description of what Earth was like for these first, say, 700 million years of the Haitian eon. Our next eon, of course, was the Archeaneon, and this is going to be the eon where we first have life appear in these newly forming oceans. And so the oceans and the atmosphere were still much, much different. When we say that life appeared, I'm not talking about multicellular life. I'm talking about tiny single-celled organisms that only lived in these new oceans. They would have been much like bacteria. So please keep in mind that our first continents would have formed during this era. Okay, our atmosphere would still have been unbreathable, but we did have some oxygen, which is what makes our atmosphere breathable, begin to accumulate in the atmosphere at about this time. Please notice that this eon lasted about 1.4 billion years. This is almost a quarter of Earth's history, and the only life that was on Earth would have been tiny, tiny bacteria that only lived in the ocean. There would have been nothing living on these early continents. Then we move into the Proterozoic eon. The Proterozoic eon lasted for nearly 2 billion years. During Proterozoic, the oceans, the atmosphere changed immensely, and then life really had some changes toward the end of this eon. We had our first multicellular organisms appear, and that's because these cells began working together. So multicellular organisms were a big step because no longer did we just have single-celled organisms. We had organisms that would be larger, things that we could see without just a microscope. Oxygen continued to accumulate during this eon. During this eon is also when the Earth at one point cooled and most of it froze, including the oceans. and we had our ozone layer appear. And our ozone layer is that part of the atmosphere as the oxygen accumulated, the ozone layer formed, and that's the part of the atmosphere that protects us from that harmful radiation from the sun, that ultraviolet light. And the last eon, and it's the eon that we are still part of. This is only, this eon started about 540 million years ago, and this eon started out with what's called the Cambrian explosion. And to start this eon, there were many, many new types of life, and there were lots of new body plans that weren't seen in the fossil record. All of this started out in the ocean. There was still really nothing on land, but over the course of this eon, we have seen, the biosphere just get more and more diverse. So the Phanerozoic eon is really one that is characterized by life. So, as we sort of, I don't need you to understand this fully, but I do want you to sort of keep in mind that as we look at sort of how life has come into being here on Earth, I want you to think of it as life started out simple and it moved to complex. Another sort of general idea that I want you to keep in mind is that life started out first in water, in the oceans, and then moved to land. So from simple to complex, from water to land. And so we can look at sort of these important bits and pieces here, these important events for life on Earth. We can see here when some of the first fish appeared, and so fish have only been around really about 500 million years. Our first land plants would have so plants first started to colonize the land about 450 million years ago. We had something that was not a fish exactly, but it was still a fish. About 375 million years ago, we had a fish that could move across the land, probably trying to take advantage of this new niche in the ecosystem. We had our amphibians appear, and then amphibians appear before our reptiles. So reptiles are, of course, dinosaurs were reptiles. So our first reptiles appeared about 320 million years ago. Dinosaurs, our first, you would think of as dinosaurs, the sauropods, appeared about 240. We had mammals, which are the furry things, about 220 million years, then birds, and then of course we had the dinosaur extinction. I want to point out that our first hominids, the first early humans, the first things that we consider to be true human ancestors, did not appear until 7 million years ago. So think about like how little time even our earliest ancestors have walked the earth. Really quite incredible. So guys, that's really going to do it for today. I really just wanted you to get a really rough idea of how life has changed on Earth and how Earth itself has changed over this vast period of time since it's formed. We're going to continue to sort of play with this idea of how Earth has changed over the next few lessons. I hope you have a great day.